Hello and welcome to this Unity tutorial on the Unity input system in 2020. It's just a quick preview to show you what you'll be learning in this tutorial. You'll be able to move and rotate on all 6 axes. Here's pitch, here's yaw, roll. We'll also have side to side, up, down, and of course, forwards and backwards. Now, for those who want to go ahead and type out the script so that you can follow along easier during the tutorial, if you're one of those people who like to type and follow along, here is the entire script: player, spaceship, movement. Also, you might be the type of person that just likes to just wants to see the script and go figure things out for yourself. This is all of it right here. Pause a little as I go down. That's it. And you'll have to set up the input system this way. Your Unity input system control map. This is a movement for the Z-axis setup. These will be add 1D composites. Otherwise, you can see all the settings on the right. All the rest of them are exactly the same, except for the key stroke changes. And for everybody else who wants to see this built completely from scratch, here we go. All right, I want to start from scratch so that everybody is on the same page throughout this tutorial. We're going to be using Unity 2020.2.0 F1. If you're close to that, 2020 or above, you'll probably be all right. But that's what I'm going to be using. I'm going to make a new project on the Universal Render Pipeline. Let's call it Unity Input System Move and Rotate Tutorial 2020. Great. I'll probably speed it up here a little bit. Okay, let's clean up some things we don't need. We won't be using example assets, README, tutorial info, example assets here. Get rid of all that. Also in scripts here, let's get rid of the simple camera controller. We're going to put in a free look camera with Cinemachine. And this part of it right now, we're just setting up the Unity environment the way we want it for this tutorial. And it's looking pretty good. So I just clicked through everything. Make sure you've got it to match. We ought to be all right. Let's save what I've got so far. So now we need to add Cinemachine and the Unity input system. Go to Windows, Package Manager. Here in Packages in Project, choose Unity Registry and go down till you find Cinemachine right here. You may have to update some of these. If you do, that's fine. Just go ahead and update them. We're going to install Cinemachine. Okay, that's installed. Now we also need to go down and get the Unity input system. Install it. Once again, you might need to do an update on it. If you do, it'll say update out here to the left of them. Now, after it does the input system, it's going to ask you to restart Unity, so that, because right now it's working off the old input system. And it says, do you want to enable backends? Doing so will restart the editor and will disable the old Unity input APIs. I'm going to say yes, but just so you know, you can use a mix of the two. You go into project settings and it will let you do it. I don't think it'll let me do it right now, but I'll show you where it's at when it comes back real quick. Let's let Unity do its thing. Okay, close out Package Manager. And like I said, I'll show you here. Build settings, player settings. I said project settings. You will go under, try to see where you could find to set them both. There it is. It's under Other Settings. in your player settings, come all the way down to active input handling, the input system here. And you can use the old, you can use the new, which is what we've switched to, or a combination of the two. I'm trying to learn to do with the new as much as possible, because if that's what they're going to, might as well learn how to do it. Plus, what I've learned so far and making my own game, I like it. I mean, once I got my head around it, it's great. So here we go. For right now, though, we're just going to set up this environment. The first thing we'll need is a ship, something for you to fly around. So we're going to make an empty game object. Let's just call it Spaceship. Underneath that, let's put in cube. We're just going to build us a little spaceship. Something we'll be able to see that has a definite front end to it. Let's get around behind it. I like for that blue arrow to be pointed away when I'm dealing with making movement stuff, because that's forward. The blue arrow here going away because it goes positive when you're going in that direction. You'll watch. I grab the blue arrow. See, we're traveling positive up here. We went from 0 to 1678. I just things I do to keep my head around what's going on. Let's scale it out on the z-axis a little bit. And why don't we also add I'm just doing something for fun here to make us a ship. Make whatever kind of ship you want. Let's say a cylinder. Okay, and let's make that cylinder the same on X and Z. Let's make it 3, 3. But on Y, let's squish it way down. There we go. I'm gonna bring it up. And we'll slide it forward. And let's make a couple other cylinders. Let's make one. Let's rotate that on the X 90 degrees. And drag it over about negative 0.5. Let's raise it about negative 0.5. Oops, went the wrong way. 0.5. Move it on out here. Just for fun. I know this is a tutorial on movement, but I'm just taking a few minutes here to have a little fun with this doodad. And let's duplicate it. See, where are we at on the X over here? We're at negative 9.1. So we'll just make this 1. There you go. Now we have a spaceship. It probably doesn't look familiar at all. So don't tell Paramount. We could get sued for copyright infringement here. But anyway, we've got all these. That's one thing I do, something that I'm noticing in my game. Make this. Hold on, I'm going to parent all these. I'll show you why in a second. Make this set standard with a 1:1:1 scale, and then you can change out your models however you want underneath. And that way, after we've hooked the scripts and everything for movement to this empty game object, all in here, if we ever decided we wanted a different model, we just switched all this out for a different model. I'll be showing you something more on that in just a second, because I'm going to use some of my assets from my own game. But anyway, here we are. We've got a starship. It's pointed along the z-axis, which is the way we want it oriented. And let me see what else we need. Next thing we should have is a free look camera. So go up here to Cinemachine, create free look camera. Put it on there. And we are going to tell it to look at, over here on the right, we've got in the inspector, Cinemachine, free look, our spaceship. We want it to follow it. And we also want it to look at it. So Here we go. And we've also got to, I think I had to parent it somewhere. Oh, we're going to get an error if we don't do this. The main camera, pull out this script. That was that camera settings. So we don't want that. Oh, and one thing it's already done for us also, I'd like to point out, when we made this the free look camera, on our main camera, if you look, it has already added the Cinemachine brain component. So if for some reason it didn't do that, and you don't see this little icon here, the gear with the red flag, make sure your main camera has the Cinemachine free look component on it. Now, when you're dealing with the free look camera, what you'll see is this rigging right here. Your top level, your middle rig, and your bottom rig. That's controlled here, top rig, middle, and bottom. And we're going to make the radius bigger because we don't want to be right up on our ship. I'm going to say 10. And these other ones, we're going to raise them up a little higher so that we're not right on. Let's say 10. And the bottom rig, -10. That'll give us a good swing all the way around our ship. You'll see what I mean when we get to playing with it. I think that's our setup for everything we need in the scene. Oh, we need one other thing in our scene. Let's look at our main camera. Yep, we got our ship right in front of us. That's great. But what we will also need is we need to put something out here so that we can tell we're moving. So just make a sphere, and we'll call that sphere moon. Let's scale that thing up. Let's go to scaling, grab the middle, make us a giant Death Star. Okay. Where it's located, it really doesn't matter. Just put it out here somewhere around the ship. Somewhere where it'll be in your view when you get to moving around. I might have put it too far out. See if the camera can see it. Yep, it's right off to our right. That'll be fine. So now, you know, when we do get our movement controls going, we can see our ship move. It's something for it to move around. Otherwise, it'd be hard to tell. It's just in big gray space. But let me go over everything, see if I've got everything I'm supposed to have. Okay, we also need on the free look camera, go ahead and add Cinemachine input provider. You'll see what that's for momentarily. Our spaceship, go ahead and add a character controller. Yeah, we ought to be in pretty good shape. Now I'm going to go down to the spaceship here. And there's the character controller there in the middle. Yeah, I'll just leave it the way it is. It don't matter. But that's how we're all set up. So we got our moon sitting here. Free look camera is set up with the Cinemachine free look script and the input provider. Our spaceship is set up with the character controller. And we're pretty much ready to go. Now, one thing I'm going to do is, just for fun, I'm going to use some of the assets from the game I'm making, Hidden in the Stars. So I'm going to pull in a few things from that. But if you've got this right here, that's fine. Everything's going to work just the same. I just like to have a space background when I'm doing space movement. Okay, we've got a nice space background now with a ship. Like I said, this I made on Blender. The background you can get off Unity. But if you're still on the ship we made at the beginning, that's just fine. They're going to do the same thing. So we're ready to start making our input maps for the Unity input system. First thing I want to do, let's make a folder that says input system. We'll name it because that's where our input map's going to be. Go into the input system, create, all the way down to the bottom, input actions. We're going to call it our input system control map. I like to be very detailed in my naming. I'm going to double click it. So I'll make it nice and big where everybody can see it. We start on this side and we move to the right. Action maps is a map for a particular object. So right now we're going to make the action map for our CM Free Look 1 camera. So let's call it CM Free Look 1. Let's call it camera, so we know it's camera, which we will, but camera controls. Now that just gives this set of controls a name that we can refer to it in script. But in as far as this mouse goes, we won't be having to script anything to get it to work. It'll all work through the input system. When we get to maneuvering the ship, we'll actually be scripting to those controls. But for now, this will move the camera. We go to new action. Let's call it mouse look XY. I'm naming it that because that's just going to track my mouse movement around the screen in XY, 2 vectors. Let's go over here and make this a pass-through. The reason we're making it a pass-through is we just want it to go from the control to the input provider, hooked to the control, hooked to the object, and them to use it. Otherwise, we would want a value or a button. Let's make it a vector 2. This particular control is going to need to know the XY position of the mouse on the screen, so that will return continuously a vector 2. Let's add a binding to it. We don't need to get rid of one. And we're just going to make it a mouse. So just put in a mouse and delta, the delta mouse. That's all we really need to get the input system to pick up the input coming from the mouse. Just create an action map. Then we'll create, let me double check my notes, I'm telling you right. Yep. Then we just create the controls that go to the map, because the reason it's doing it this way is because, let's say the controls for this camera had a whole long list of controls. So now you can refer to those whole long lists in script if you needed to through one action map. And this just defines the type of action it is. So we're just saying mouse XY, and it's just a mouse move. That's all it is. I'm going to put it on autosave so it doesn't mess us up from now on. And we should be good to go. Let's close out the input system control map. Let's go back to CM Free Look 1. We go back to that Cinemachine input provider that we set up. And if you notice, it's already has XY axis and Z axis for mouse movement. This would be for panning and zooming if you wanted. But all we need for right now is to click here and choose the input control we just configured, CM Free Look 1 camera controls / mouse look XY. And it's in place. So that should do it. Let's see if I got set up right. Yep, there it is. Very easy. We've just created a 360-degree camera control for our ship. Easy as can be. Okay, next we're going to do the controls for the spaceship itself. So we go back to our input system, control map, double click it back in assets if you've closed it back up. The last thing we did was a free look control map. So now we need a spaceship. So we'll call it, click on action maps, the plus again. We will call it spaceship controls. Simple and sweet. Now the actions are which buttons we're going to push and what they need to do. Now this is going to be a little different in this action setting than it was in the mouse. The mouse returned a preset input provider to the free look camera. But now we're just wanting to pick up keystrokes in our script. So the input that we put in here moves nothing. That's important that you understand it to wrap your head around what's going on. This will move nothing. It's just going to return values that we can use in our script to then move the ship. So our first action, we're going to call movement, thrusters. Well, let's make it simple. Let's just call it z-axis. It's going to be a button. Remember, before it was a pass-through because we were just sending the information, the XY coordinates, to another script that Cinemachine was using. But this time it's going to be a button because it's what we're using. I really haven't used value yet, to be honest. But we're going to make it a button. So a button just means we want to get information back from a keystroke. We're going to click here. Instead of just adding a button, we're going to add a 1D axis composite. The reason we want a one-dimensional axis is because this Z thrusters, the Z axis, is what we're going to be moving along. We want something to tell us we went forward. We want something to tell us we went backwards along this axis. So, using the good old WSAD method, the path is just the button you want to push. Hit listen, S, I'm going to tap S, and put in negative S keyboard. In other words, just like an FPS and everything else, S goes backwards. So right here, what's this going to be? Listen, W. W is going to take us forward. So basically what this binding is doing, I'm going to get rid of this one because it's not doing anything. What this one is doing is if I press S, this input system is going to return to the script -1. If I press W, this input system is going to return to the script 1. And if I press them both at the same time, it's going to give me neither. It's just going to stay 0. So really, this 1D axis only returns 3 things. It returns a -1, a 1, or a 0. And we use those in our script to move our ship. Okay, we're going to go on and lay out the last 5 settings. But before I do that, I'll show you something just real quick. If you've ever wanted to set up a button to hold or to double tap and stuff like that, this is where you would do it, because you can also set up your controller buttons this way. You just add these interactions to them, and some also processes if you want to set normalize and clamp, some dead zone information, stuff like that. But I just wanted you to know where that was in case you need it and you ran into it. But we're going to lay out the last interactions. We'll just go down the list pretty quick here. Movement, X-axis. Let's get rid of this. Add in our D-axis composite. The next one will be movement Y-axis. Same thing. Delete. Add that in. Okay, now we've got our 3 movement axes, Z, X, and Y, which should be, let me reset this, just simply back and forward, left and right, up and down. So now we're going to go into rotation. The actions will be rotation, Z-axis. Ditch that again. We still just need the 1D axis composite. Rotation X-axis. Deleting. Oops, got ahead of myself. Can't click right now. And rotation Y-axis. So now we got to go in and add our keys. So for movement on the X-axis, a lot of times you would think to strafe. In other words, in an FPS you do this. But in this shift, so you use A and D. But in this game, I want to use A and D for my rotation there. So in this tutorial. I want to use A and D for my rotation there. So for my x-axis left and right, I think I'm going to use, we'll use left shift to go left. And I'm going to use spacebar to go right. I know that seems weird, but stick with me. I kind of like it. All right, movement on the y-axis is up and down. Of course, we want to go up and down like this. So positive, I'm going to use Z for that. And for the negative to go down, because I'm thinking crouch, I'm going to use C. Now we want to do our rotation. So it gets kind of strange here. Rotation on the Z-axis, since Z runs this way, along this line, and it's the blue one, that's where we get our roll. So let's go back, and I think I'm going to use, for the Z-axis, to roll left, I want to go Q. And to roll right, I want to go E. Now on X-axis, that's where our pitch comes in, up and down. So let's see. To go down, to dip our nose down, I'm going to say R. And back up, I'm going to say F. And if we get to playing around with it and we don't like any of these, we just come back in here and change them, even after we've made the script and everything. Because that's the great thing about this. You write the script, and if you need to change your controls, you just come in here and change them. And you can even change these through scripting. So if you want to make your controls user configurable, you can change these through scripting also during the runtime of the game. Y-axis, that's our yaw. So I just thought it would feel more natural to still have A and D on that. So I'm going to use A for that and D for that turn. So let's look down through here and make sure everything looks good. Z-axis SW, X-axis left shift space. We'll be sliding back and forth. Y-axis up and down CZ. Z-axis roll is QE. X-axis pitch is RF. And Y-axis turn is YD. So that works out pretty good. So from here on out, the next part is we'll be writing the script that interacts with this and actually gets our ship to moving. All right, let's go ahead and make our script for this. What we're going to do is go into scripts, create a new C# script. Let's call it player space ship movement. And double click that. We're not going to need start for this. And to set it up, we're going to need quite a few variables. So what I'm going to do is go ahead and type them all in, and I'll pan over it so that you can catch up. And then once we all have them together, I'll go down the list and explain what each one of them is for. All right, I'll pause right here and give you a second to type all these in. This is all the variables we will need for this movement script. Okay, starting from the top, since this script is going on our player spaceship, the ship we're controlling, we'll need a reference to the character controller so that we can move the ship on the X, Y, and Z axis. So when we put the script on here, it will be referencing this component. Why don't we just go ahead and put our script on it. Now, the next line, private transform, player ship transform, is simply another reference to this, our own ship in the transform. And we go on down, serialized field private input action asset controls. What this is a reference to the input system that we created, all of our maps. right here. So what we can do is go ahead to our spaceship. Let's go ahead and slide that on in place. Now, from here on down, it's just references to different speed variables for the ship. What we'll want is, when we're moving our ship, we don't want really harsh movements. Let me show you here. Say if I press forward, I don't want my ship to take off and stop immediately, or to take off and stop immediately, to slide left or right, take off and stop immediately. What you want is it'll slowly raise up to speed and slowly go back down when you let off the thrust. So the way we'll do that is through keeping it with acceleration, the current speed, and the max speed of our object. So we have fields for movement, 4 of them, and 4 sets of fields for rotation. They're basically mimicking each other. The first one, movement acceleration z-axis, which is a float. This is just the amount of time it would take for our ship to get from 0 to its max speed along whichever axis we're tracking here. Movement max z-axis speed, that is the max speed of the ship along that axis, and we'll set that in the inspector. Same with this. Movement z-axis, these movement variables are for the input control map. Like I said, we're going to get, like if we press S and W, it's going to return -1 and 1. Well, the movement z-axis is what's going to capture that variable. Movement current z-axis speed, we need to keep this because it's going to help with that smoothing effect where we go from 0 to max speed and max speed back to 0. Same way with all the rotation controls, rotation acceleration z-axis, rotation max z-axis, rotation z-axis, and rotation current z-axis do the exact same thing as movement. It controls the maximum speed and the smoothness of our rotation when we're rotating our ship on those 3 axes. And now we will, oh, let me do one thing I wanted to add in. Let's go ahead and do this. Before that, let me even tell you this. When you put in input action asset, you're going to have to add using Unity Engine input system. So remember to do that. And also let's add this. We're going to go require component, type of character controller. What this will do is if we put this script on a game object and we've forgotten to add the character controller, it just forces the script to automatically add the controller for us. All right, now we're going to set up the commands that will capture the input from our input system, where we set up our axes and lettering, such as the S and W, capturing the values -1, 1, or 0. Now we're going to set up the commands that will capture that for us. What I'm going to do is type them all out, speed it up again, and then give you guys a chance to type it behind me, and I'll go over them one by one after that. All right, here we go. What we need is a private void awake method, and we're going to put these commands in it. Our controller, we're going to go ahead and have the game object grab the component controller. Remember, we set these variables up at the top, controller and player ship transform. Same thing with the player ship transform, game object get component. It will just automatically do it. That way we won't have to set it in the inspector if we do it here in the wake. Now here's the tricky part. This is where we're grabbing the movement values out of the input system. Controls, remember that was our input action asset. It's our reference to our action map itself. And we're just going to drill down to the control. Find action map. Our action map is Spaceship Controls. Here it is, Action Maps, Spaceship Controls. That's what it's referring to. Find action, movement z-axis. So we drill down one more level to the actions, movement z-axis. and then we check if it has been performed. In other words, if one of the keys have been struck. If it has, it assigns it through context, to movement z-axis, and it tells it that it equals the value that it just read in the context of whatever key was pressed, what action was performed. Also, right beneath it, if you'll notice, it's the same mapping, and it goes down and says canceled. And if it's canceled, which means neither key is being pressed, then the movement z-axis is changed to 0. I love the way you do this. You don't have to write big controls, big ways to monitor your controls in the update statements. We still will have an update method, but I love the way this is handled here. It just sets it up to be monitored as long as the script exists. And it's great. We do the same thing for every axis on down the list. Here's your X, movement X-axis, movement Y, and then same thing for your rotations. Rotation Z, rotation, look what I did. We'll fix that real quick. Just make sure you got it all right. I made a mess, but it's real quick to fix. There we go. Corrected it. And that is how we set it, the script up to capture our values coming back from our input system. Okay, this next part is just something required by the input system. I don't know why, it's just the way they have it set up. It looks like once establishing them in here, Unity would just know, but we have to do this. Private void on enable controls. Remember, same things up here, our input mapping again. Find action, movement, z-axis. Basically, we have to enable each action in here. Each action, these green lines, have to be enabled when the script starts and disabled when it finishes. So here we go, enable. And I'm going to speed it up and type the rest out, give you a chance to catch up. Okay, I'll give you a few seconds to catch up, type all that in. Once again, I have no idea why it's required. It just is. All right, we're in the home stretch now. One method left, our update method. Once again, I got quite a bit of code to put in here. I'm going to type it all out and pause for a minute while you catch up. Okay, we'll stop right there. I'll pause a few seconds, give you a chance to pause it and catch up on this method, typing it in. All right, we'll stop from the top. What we're doing is movement current z-axis speed. That means the current speed of the game object along the z-axis. And the way we're going to figure that is we're going to use the math lerp function. And if you look here, it says the interpolated float result between two float values linearly interpolates between A and B by T. You have to excuse my pronunciation. I can barely talk. But anyway, what it's saying is it's going to go from this speed to this speed by this amount. So if this was like a 0.5, and let's say this was 0 and this was 6, then it would take 12 frames for it to interpolate from 0 to 6 by a half a unit every time. And what it's going by is the z-axis speed. Let me go back and show you. I'm going to load up here. The speed is regulated by the units here. This is a unit, this is a unit, this is a unit. And I think it's how many units they travel in a second. which would be a meter. So if you said 6 in 1 second, it would travel from here 1, 2, 3, 4, 5, 6. So in 1 second, it would move about this far. I hope that helps. But anyway, we'll do a little quick math on this. So if we're going to set our movement max z-axis speed, let's say on the z-axis, the fastest it can go is 25. Then from 0, it'll interpolate from 0 to 25 by the smoothing amount here, the acceleration z-axis. So if this is 2.5, let's say we want 2.5 seconds for it to go from 0 to 25, then this is what it's going to do. It's going to multiply it by time dot delta time, which is it's hard to explain. It's keeping up with how many frames that your computer is displaying in a second, I think, and dividing it up. It's hard to explain. But anyway, just know that it helps smooth things out. So we do the same for the x-axis, the y-axis, and even the rotation. It's basically the same function on both of them. And like I said, it just helps smooth out the movement. And all right, now we come down to which brings us to the actual move and rotate of the ship. Controller, remember that was our character controller. So we're saying move. And some people separate this out. I kind of just combined them into one line, one command. Transform forward times movement current z-axis speed. It's getting this, of course, from here, telling it how fast it should be traveling in that frame, because every frame is an update. And time dot delta time, it helps smooth here too. Forward is the z-axis. Then we come down here, right is the x-axis, and up is the y-axis. So in this one move, it's looking at what the current z-axis speed is and moving at that amount in this move. And if this might help make a little more sense too. Since movement z-axis is the value caught from the input system, right? Whether it's 1 or -1 or 0, if nothing's being pressed. So think about it. If the movement current z-axis speed is 0, meaning the ship was totally stopped, and we pressed W, of course this would be 1. So it'd be 1 times whatever we set the ship's maximum speed to be, whether we want it to be 25 or 10 or 6 or whatever. So it's interpolating between 0 and 1. By this amount to smooth it out, time in seconds. Now if we let off, movement z-axis becomes 0. So now we're interpolating between 0 and 0, and the ship stops. So that's why this works, because it takes into account whether it's 1, 0, or think about it also, it could equal -1, which would be just like saying negative transform forward, which would be in reverse. So now we're multiplying and making it all a negative value. Movement current z-axis speed is negative multiplied times this makes it negative. Same thing with the ship rotation. It's a little simpler. All you have to put in is the rotation current x-axis speed and the time dot delta time. There's no transform forward, right, or up. It's just keeping up with how fast the ship is turning. And we'll see that all in just a minute. Okay, here we go. Moment of truth. Let's go find out where all the bugs I left are. Go into Unity. Let's go to our spaceship. Here are all our variables set up. Now we need some speed set up or it's not going to do anything. We got to set max and the acceleration. So acceleration on Z, let's just put them all at 2.5. Make it simple. Z axis speed 25, I want to go forward. 10 for Y, X and Y speeds. Let's go down to rotation acceleration. Let's make them all the same. We just want to be able to see the ship move. I'm going to just put all these at 10. And the rest, we don't have to set anything. That's I really should have set them up to where they didn't appear. Serialized them or something. I thought I did. Hold on. I mean, not serialized them. Let's see. We needed acceleration and max, but we don't need these to be visible. I'm going to just leave it. We may want to see what it's doing. Who knows? All right. Moment of truth. Let's see where the bugs are. Ship is... Turn the camera so we got the little moon behind us so we can tell if we're moving or not. Hey, it worked right off the bat. And if you notice we're going forward, only the Z-axis is moving up. Let's go backwards. The Z-axis is negative. The camera's fighting me. I think I'm going to have to come up with a better idea for this camera. But anyway, let's see. Yep. Left. Right. Yep. Let's see, we got up and down. And if you notice in the transform, how it takes it a minute to stop. That's the smoothing going on. Let's see if we got our, yep, we got our tilt. Got our pitch. And I wanted our rotation on A and D. There it is. Remember, you can speed all this stuff up. Hard to see unless you keep it around the moon. But that's it. We've got them all working. So I hope this is of help to anybody who needed this. And I'm planning on doing a few more tutorials after this. If you want to keep checking back, I'm going to do the zoom tutorial so that you can zoom in and out on the ship here and with the scroll wheel, and also the trail renderer, which you saw in the intro where the ship had the lighted trails following it around. And I appreciate you hanging out watching my video. Hang on just another second and I'll show you all my websites and pages you can keep up with these projects. Thank you. The assets used in this video were from my new multiplayer Starship game in development, Hidden in the Stars. If you like this video, remember to like, follow, and/or subscribe at Corky Software Design on YouTube and Facebook for more tutorials, or on YouTube at the Hidden in the Stars channel for more game development info. Thanks for watching.